Hi, welcome. In this new lesson, what we are doing is creating our items API. So in order to do this, we are going to use our model view controller pattern, our MVC, and in a little difference between the items API that we are going to create and the users API or the OAuth API that we have created is that in this API we are going to use Gorilla Mux as an HTTP server. Okay, now this is the library that we are going to use. Instead of Jingonic, we are going to use Gorilla Mux as an HTTP framework. Okay, so as you can see, Gorilla Mux, a powerful HTTP router and URL matcher for building Go web servers with Gorilla. Okay. Now let's start by importing our project. So github.com, my username, and here we have our items API. Okay, so as you can see here, we have our basic git ignore and the README that we have just generated using GitHub. Now what we are going to do here is just by starting the application is ignoring our that idea folder, that is the folder generated by this tool that I'm using. And also, since I'm using Mac OS, I'm going to ignore every file called dsstore. Okay, and that's because I don't want these files to be committed in my GitHub repo. Now, since we are using model view controller pattern, let's create our folders. So we have our controllers. Okay, this should be a folder. There we go. So we are creating our controllers slash items controller. Let's go. There we go. Then we are creating our services slash items service. Let's go. And finally, since we are working in the items API, we are going to create our domain. So domain slash items slash item.go. Okay. So this is the basic structure that we are going to have. Now, since I've been talking from the beginning of this course, if we are starting a new project, in this case, the items API, we need to focus on the item. Okay. So every layer, every pattern, every HTTP router, or any other library that we are using is there to provide this item to the outside world. Okay, so someone is able to interact with our item to create an item, to retrieve an item, to search for a given item. So this is the core. This is the core of our microservice. So let's start by defining what an item is. So we have the item being an struct. Okay, just like this. So in order to define an item, what we are going to do is take a look at basically the fields that we want to have in our item. So in this case, let's start by creating our item ID. In this case, being a string, just putting JSON ID. Okay. Then we have the seller being an integer 64. So this seller will be provided by our users API. So in this case, seller. And then we have the title being a string, working, for example, with JSON title, like this. So we also have the description being a description, and the JSON will be description, just like this. And the reason I'm putting description as a nested structure here is because what I want to do is provide support for both plain text or HTML descriptions. Okay, so plain text being a string, JSON plain text, and finally HTML being also string with JSON HTML. Okay, just like this. Now, after the description, we have our pictures being a slice of picture, and these are the images for this item. Okay, so let's define what a picture is. So type picture being a struct. So in this case, we have the ID of the picture being an integer 64, JSON ID, and finally the URL being a string with JSON URL. Okay, just like this. Then what else could we have in our item? Let's suppose a video, for example, being a string. So this will be the ID of a YouTube video that we have. Okay, so video. Then let's talk about pricing. Okay, we have the price being a float 32, JSON price. Then we have the available quantity. Okay, just like this, being an integer. So we have integer quantities being available quantity, just like this. And we have our, let's suppose, our sold quantity. Okay, how many items have been sold? Sold quantity. And finally, we have the item status being a string, and the JSON is status. Okay, just like this. So this is what basically an item is for us. You can modify this struct to have the amount of fields and the configuration that you actually want, and according to your business. So in this case, since this is a really startup or basic application, we're just defining the item like this. Okay, so this is the domain. So the entire API is here to interact with this domain. So now that we have our, let me show you something over here. On the model view controller, what we are going to do is create our items controller. Okay, so the item controller will be in charge of receiving the request, validating if we have all the parameters that we need to process that request, and if we have them, we are sending this request to an item service. Okay, so in this case, we have the entire business logic to handle items. So in the service, we have the logic for saying create an item, retrieve an item, get, search, delete, or update a given item. Okay, so as you can see from the controller, we are sending the request to a service. And this is the input layer of our application. So in here we have all of our business logic in the item service. And finally, what we are going to do here is work with our domain. Okay, so as you can see here, we have our item, the domain. So this is the core of our entire system. Okay, we have the controller, the service. So the service is interacting with the domain and persisting this domain in what we are going to use. This is Elasticsearch. Okay, so as you can see here, what we are doing is basically persisting this item into Elasticsearch, just like this. So this is what we're going to build over here. And as you can see here, the Elasticsearch is going to have items. Okay, so the domain is going to be persisted in our persistence layer. So we can change the persistence layer and use MySQL, Cassandra, MongoDB, or any other type of database that you want to use because you have analyzed that that's the best choice for your system. So in this case, we are going to use Elasticsearch. Okay. Now, the good thing, and what I want to stress in here, is that over here we have our HTTP router. Okay. So as you can see here, in this case, we are going to use Gorilla Mux. Okay. So this router, I'm going to use, okay, I ran out of colors. Okay, nothing here. I'm going to use this one. There we go. So as you can see here, the user, or the actor in this case, the user, is interacting with our router. Okay. So the router is the entry point of our application. Here's where we have the HTTP engine that we are using. And we are sending this request to the items controller based on the HTTP method from the request and the body that we have, okay, and the path that we have. Now, as you can see here, we can change Gorilla Mux, or we can use Golang, or we could use any other HTTP router that you want, or we can use just a plain HTTP request without any HTTP router, and that will be fine. Okay, as you can see here, the HTTP router that we are using has nothing to do with the structure of our application. Okay, actually we can change this layer as much as we want, and the only layer that should be just a little bit modified is the controller, because over here we have the handlers corresponding to a given request and response. Okay, but as you can see here, this is what we are going to build. So the difference between the items API that we are building and the users API, for example, is that the structure that we are going to use for the controllers and for the providers, okay, for the clients or the external providers that we have, in this case, Elasticsearch. Now let's build this in our application, okay, and we are not talking about the router yet, okay. So we have our domain completed. That's the first thing that we did, working on the domain. So we started working, as you can see here, we started from here, okay? And this is something really, really important, because if you start from here, you are focusing on what's the provided layer that you're going to use and what's the structure of your application, instead of focusing on what you're going to provide, okay, what you're going to serve. So this is the reason why we always start from the domain, okay? We always start modeling our domain. And that's the really good part about what we are about to do. So we start from the domain. And now that we have the domain, let's take a look at the service. Okay, so what do we need in order to provide the service functionality? Now, in this case, we are starting with the service. So the first thing that we need to define is what's the interface that we are going to provide to the callers for this service. Okay, so in this case, we are creating our items service interface, being an interface, okay, just like this. And we're saying that we receive and we provide this functionality for creating a new item. Okay, so the create function takes an item as a parameter, and as a result, we return a pointer to items.item, okay, the item that has been created, and a rest error, okay, this rest error being the rest error that we have defined in our URLs, okay. Now this is the interface for creating an item. We receive an item as a parameter, and as a response we return, actually, since this is the interface, I can just remove the name of the variable, the name of the parameter, And as a response, we have a pointer to an item in case we don't have any error and we can create this item successful. And in the case of an error, we respond a REST error. Okay. So the other functionality that we are going to provide is get an item by ID. So in this case, get an item, we'll receive the item ID. So as you can see here, the item ID is a string. So that's exactly what we'll receive as a parameter. And the response is pretty much the same as the response for the create. So if we can find this ID in the database and we don't have any error, we are going to respond an item. Otherwise, we're going to respond an error. Okay, so this is the basic interface of what we are going to develop. Now that we have the interface, what we are going to do is create our items service, but now being an struct. And what we are going to do here is implement this interface into this item service struct. So in order to implement a method instead of a function, we put func, then the relation or the definition on where we are going to implement this interface, in this case item service, and finally then the definition of the function, in this case return new and new. And finally we're going to do pretty much the same, but now the get. Okay, just like this. And as you can see here, as soon as we implement all of the methods, now the item service is implementing the item service interface, just like this. Okay. So in this case, what we are going to do here is return new and REST errors. New REST error, where we say the message is implement me. The status is going to be HTTP status not implemented, and the error not implemented. Okay, and new. And the same over here. So we don't have these methods implemented yet, so that's what we are returning. Okay, and as you can see here, we have our struct implementing the interface. Now what we need to do is make this struct available to the outside world. So in order to do this, what we are going to do here is create our items service, being of type item service interface equals a pointer to our items service. Now what we are doing here is basically create a new variable called item service, being of type item service interface. Okay, the type of this variable is this interface over here, and the value of this item service is a pointer to item service, being this struct. And since this struct is implementing this interface, we can do this. Okay, as you can see here, if I change something over here and I don't implement one of the methods, you can see that we cannot use item service as type item service interface because the type does not implement the create method. Okay, so there we go. This is our item service. So we have the domain completed. We have the interface defined in the service, and now we're going to work on the controller. Okay, and here's where we are going to make a difference between this API and the users API. So let me show you something over here. This is the users API, and as you can see here in the users API, we are using packages to differentiate between different controllers. Okay, so as you can see here from the URL mappings, you can see that we are importing controllers/ping, and then this package contains all the ping controllers that we have. In this case, just one. Over here we have controllers/users. So in the users controller, we have our users controller. Okay, just like this. So what we are doing here, instead of making this approach, what we are doing is putting all of the controllers in the same package. Okay, and by default, what I'm going to do here is develop in this way. Create, okay, and finally the get. Okay, so we are implementing the two functions, in this case functions, not methods, to be able to retrieve a user, or to create, actually to retrieve an item and to create a new item. So first, what we are going to do here is work on the create. Okay, so let's take a look at the library and how this works. So over here we have our handlers. Okay, so as you can see here, we have our router, in this case Mux.new router. So as you can see, comparing this with our Gingonic, we have our router being Gin default. So in this case, instead of Gin default, we have Mux.new router. And then we have the handlers, okay? Handle func. And as you can see, a handler over here takes this interface. W being HTTP response writer, and R being a pointer to an HTTP request, okay? Response and request. And as you can see here, this is the interface that we need to implement on a controller, okay? The difference between Gorilla Mux and Gingonic, as you can see here, is that Gingonic requires you to develop the handlers in this way, where the handler receives C being a pointer of Gin.context. So that's the main difference when using Mux. In this case, we need to implement in this way. So that's exactly what we are going to define over here. So we have the response and the request, and the same over here, okay, just like this. So what we are going to do here is, since we are creating an item, we want this request to be authenticated, okay? So we are requiring an access token in order to create a new item. So the seller from the item, okay, let's take a look at this. This seller is going to be taken from the access token information and not from the JSON request, okay? So over here, we will require this request to be authenticated. So just for now, what we are doing is, if error equals OAuth, okay, so if error equals OAuth authenticate request, and OAuth being our bookstore OAuth Go library that we have developed, okay? Now this OAuth takes, as you can see here, takes a request being a pointer of HTTP request. And as you can see here, that's exactly what we are getting over here. So we can just pass the request. If the error distinct is nil, then over here to do return error to the caller return, okay, just like this. So what we are doing here is just working on the boilerplate that we have. Now, if we don't have any error and we are able to take this, to create this item, what we are going to do here, we are not taking the request yet. So what we are saying here is, we have the item being items.item, okay, and we are saying that the seller ID, seller, equals OAuth get caller ID with the request. Okay, that's why we have developed this library, to be able to retrieve the caller based on the access token that we get as a parameter. Now, if now we have the result and the error equals services.item service, and as you can see here, we are importing the services package, being this package over here, and using this item service. Okay, so services.item service that create, and we pass the item. If error distinct nil, then return error JSON to the caller, okay, to the user over here. To the user, okay, just like this. And if we don't have any error, then what we're doing is just printing the result over here and to do return created item with HTTP status 201 created, okay, as JSON with HTTP status 201 created. So that's exactly what we are doing, okay, just like this. This is a really an overall boilerplate on what we are doing. In this case, as you can see, we are not taking the item request from the actual request, the item JSON. We are not using the response yet. So we are just creating the structure of the project. And the reason I want to do this is, as you can see, we have our domain, the service, the controller, and now we can work on the router. Okay, so in order to do this, what we are going to do is put our router same as we did before. Okay, what we are doing here is putting a new main file over here. So package main, function main. So this is the entry point of the application. And as you can see here in the users API, we have application and we have our start application that basically map all the URLs. So just by importing the package, you have this router variable initialized already. Then we call the map URLs, where basically we define all of the handlers that we have, the controllers, and the path with the type of request, the method that we're receiving, and who's the controller in charge of handling this request. Okay, and the reason we use this application over here is because, and let me show you a little difference here, I could put something like this: variable router equals mux new router. So that's exactly what they are recommending over here, new router. Then I could say something like router that, okay, in the main function, I could say something like router that handle func being /items, and the controller in charge of this will be controllers that create. Okay, just like this. So as you can see here, we have the router developed over here, the path that we are processing, and in this case, we're saying this is http.method post. So we are only processing the post request against /items, and the controller in charge of this request is going to be the controllers create. Okay, so this items controller over here. The reason we're putting this application package over here and we're putting all of this logic inside of this package is because if we want to run the application, if we want to create let's suppose a functional test, okay, where we need to actually run the application, start the application, if we have all of the logic for initializing and launching our application in the main file, then we're going to have a huge problem because we need to call the main function from our test. And that's something that we can do, but that's not the best case because we want to test how the application is defined, how it is, all the handlers that we have. We want to have unit tests for saying we know just a single path over here, and that's a post request, and this is the path. So I want to be able to modify and and test all of this functionality without calling the main function. That's exactly why we have our, over here, our application slash application.go. Okay, so over here, func start application, just like this. Okay, so in this case, what we are going to have is pretty much this. Okay, the router being mutex, the mux, that new router, and then we have our URL mappings, where we have our function map URLs, okay, just like this. So from the application, after we have the router initialized, we are saying map URLs, okay, like this. And over here, we have the URL mappings, okay, all of the URL mappings, just like this. So from our main function, what we are doing is, I'm going to change this really quick so I can find the package, application, just like this. So now I'm changing this back, and there we go. So from the main function, the only thing that I'm doing is calling application, start application. So this package has the router, okay? So from the main file, we are calling this application package, where we have the router, and then we are mapping the URLs. So over here, we have the router handle func items, and we have, this is the path that we are processing. And we are saying that when we receive a post request against /items, the controller in charge will be this items controller on the create function, okay? So this will be the handler. So let's take a look for a moment at the difference between this definition and the definition that we have over here. So if we compare the two different approaches, okay, this is the URL mappings for Gorilla Mux, and where we are not separating the controllers in different packages, but we have all of the controllers in the same package. And this is using Jingonic, but separating all of the controllers in different packages. Okay, now as you can see, it is cleaner over here, because if we say, for example, users, that you can see that all of these are the methods that we have available on the user's controller. Okay, so if I put ping, for example, you can see that the only handler that we have is ping over here, being this one. Okay, so that's why we need some sort of grouping functionality in our controller section over here, and that's exactly why we are doing pretty much the same as we did in our service. So let's suppose that we have over here our users controller. Okay, so over here I want to define a create function that takes a given user and saves or processes this user. As you can see here, create redeclare in this package. And I have two different controllers, but they are all in the same package, the package being controllers, okay? So as you can see, I cannot use the same method name, in this case, the same function name, because I already have this function name in the items controller, okay? As you can see here, create redeclare in this package. Now, if I go to controllers, as you can see here, I have create and create, two different creates, okay? One taking no parameters and the other one taking response and request. So this is not possible in Go. We cannot override methods and overcharge methods. So the other problem that we have is that if we put create item, and in this case create user, if I go to the URL mappings and I put controller, that you can see that I have get, create user, create item. Okay, so these two are from the items controller, and this is from the users controller. So I want to be able to group all of these functionalities in the same controller, and that's exactly why I'm going to create my items controller interface, being an interface, okay, where I'm going to declare two methods that I need to implement, being create and get. Okay, and as you can see, the interface required by this method is the interface required by the HTTP router that we are using, in this case Gorilla Mux. So as you can see here, a handler or controller in Gorilla Mux takes this interface, response and request. The handler or controller in Gingonic takes this interface, C being a pointer of Jane.context. Okay, so that's exactly why we are defining this interface. Now that we have the interface, we are creating our type items controller, being now an struct. Okay, just like this. And instead of defining this as package functions, what I'm going to do here is define this as methods on a given struct. Okay, so I'm implementing this interface on this struct. What I'm doing here is implementing the items controller interface to this items controller. Okay, so just like this. As you can see, as soon as I put this, now I have my interface defined, and that's pretty much it. Now, if I go to the URL mappings and I try to use controllers, that now you can see that the only option that I have available is this create user. Okay, so if I go, for example, to my users controller and I do pretty much the same, type users controller interface, being an interface requiring this method to be implemented, now type users controller being an struct. Okay, just like this. And finally I put C being a pointer of the controller. As you can see, now the user controller implements the user controller interface. But now if I go to the controllers package and I say controllers, that as you can see, I don't have any public functions or variables or constants or anything to interact with the controllers. That's why we need, same as in the services, we need our variable section where we put our items controller being of type item controller interface equals a pointer of item controller. Okay, and just like this, what we are saying is create a new variable, a public variable called items controller being of type item controller interface, and the value of this item controller variable is going to be a pointer to items controller struct. And since this struct implements this interface, we can do this type of assignment. Now, if we go to the controllers, as you can see, now we have items controller and finally create and get. And that's exactly what we're using over here. Controllers, item controller that create. Okay, so in this case, as you can see, now I have controllers that items controller. So if I go to the users controller and I put my variable saying my users controller is of type user controller interface, and the value of this variable is going to be a pointer of user controller. Now if I go to the URL mappings and I say controller stat, as you can see, now I have items controller and users controller. Now inside of the user, I have the create, okay? So I could put something like this, okay? Now, as you can see, now I have create, and now over here, I have my items controller that create. So I can have these two same functions, but in this case, since they are methods implemented to this interface, now I can have the same names and I'm grouping functionality depending on where I'm actually modifying this. Okay, so as you can see here, this is the way we are going to define our handler. So we have the application and the URL mappings. The application saying this is the router equals mux new router, and the start application saying map URLs, and then we need to launch the server. Okay, so as you can see here in the documentation, we have this one. Okay, so we have our server. In this case, this is the router that we have just defined, and the address in this case is going to be localhost 8080. That's perfect. And for now, let's remove all of this, just for now. Okay, as you can see here, the server listen and serve returns an error. So what we are going to do here is if error equals this error listing is new, then just panic with this error. So for example, if we already have an instance of this application running and we try to run this again, we are going to have an error. Now, same as before, as you can see here, we have our ping controller over here, and we need to respond ping being a string with status OK. This endpoint is used by the cloud provider that we might be using, Google Cloud or Amazon Web Services or any other that you want. They require an endpoint, a get endpoint that they can hit, and you respond an OK with whatever you want to respond. And what this endpoint actually does is saying to the cloud provider that this application is up and running. Okay, so what we're going to do here, since we already have a controller created and we don't have any users controller over here, what we are saying is this is the ping controller interface. Now this is the ping controller. Okay, in this case, being this ping controller, and we require just a ping with the same interface because this is a handler or a controller. Okay, so this is the interface required by Gingonic in order to be considered a handler or a controller. So over here we are implementing this on the ping controller. Okay, so what we have over here in our constant is pong equals pong, like this, to avoid hard coding any string in there. Then the variable, like this, then the definitions, and finally over here what we are going to say is w dot write header http status OK, and finally w dot write an array, a byte array from this constant. Okay, and that's pretty much it. We're returning a status OK with pong using the response writer. In this case, we are not taking any action on the request. Okay, and just like this, as you can see here, if we run the application, now we have the application up and running. Curl local host 8080/ping. So, oh, okay. I don't have the endpoint defined, okay? In this case, I'm starting the application just like this, 8080. And what I need to do here in the URL mappings is basically saying that router that handle func /ping. So the controller in charge of handling a get request against /ping is going to be controllers.ping controller.ping. Okay, so just like this, we go to our main file, and there we go. We have the application up and running, and localhost 8080/ping, and there we go, pong. Now, if we put this in verbose mode, you can see 200 okay, this being text plain because it is just a string, and pong. And just like this, we have our server up and running. And that's pretty much it on this initial configuration. In our next video, we are going to keep adding functionality to this API. But for now, this is what we should have and the basic structure. So as you can see here, we started working from the domain. Okay, the domain is the first layer that we're always going to work. Then the services, where we have all of our business logic, the controller in this case, and finally, and at the very end, we are worrying about the HTTP handler that we are using, okay, the router that we are using. So I really hope that you like the video. If you have any questions or any comments, please let me know. And I hope to see you on the next video where we are configuring the router and adding more functionality to this API. Okay, see you next time.